So I wanted to do a sample problem with you, and I'm hoping by the time we're done with this problem you can answer the question, why do speed limit signs only show one speed? Why don't we have speed limits for big trucks and speed limits for small cars, things like that? Why do we only have one? And I think the biggest reason there is it partly has to do with having a cohesive traffic flow. So if everybody's going similar speeds, it's kind of easier to navigate around. But I want to talk in terms of forces. Now, in the US, you may see not necessarily a speed limit sign, but you may see a warning sign for turns where it's not the white sign that you're used to. It's like a yellow, and it may have the speed posted that you are recommended to take the turn at. So again, why only one speed for this warning? Well, if we're going around in around a turn, we can approximate that turn as an arc of a wider or of a whole circle. And so the turn itself has kind of like an imaginary radius. So we can kind of view this as circular motion. We just need to pick a point along the arc to draw our free body diagram. So I'm going to just pick this point here at the beginning of the turn. We're going to have a normal force upward, the gravity pulling down on the car, and neither one of these is pointing towards the center of our turn. So there needs to be a centripetal force here, and we don't have one. Well, if we're trying to maintain the same radius, that means we're trying to prevent ourselves from sliding outward or sliding inward. So that tells us that there needs to be some sliding friction preventing us from going in and out of our lane. If it's preventing us from sliding, that would be a static friction. So I'm not talking about the friction between the wheels as they go round and round. I'm just talking about sliding side to side. So this here is our free body diagram. That is our centripetal force. So we can set mu times the normal equal to ma. We know that the normal should equal the weight, or the gravitational pull on the car. A is v squared over r. And we see that we don't care about the mass of the car. So as far as the recommended speed here, if we know the radius of the turn and what the coefficient of friction is expected to be like for a slick road, so we can just assume worst case scenario like the road is wet or the road is icy. So we set this as low as it needs to be. We can figure out a recommended speed. So we get the speed without needing friction to keep us in our lane is root rug. So radius of the turn, coefficient of static friction for that particular surface, and again we would assume worst case scenario here, and what planet we're on. That's really all we need.